Good morning, everyone. I'm Xiaohu from Huawei. Here I will talk about virtual subnet, a kind of IP-only L2 VPN service. This can be used for DCI, data center interconnect. Here I list some major requirements for DCI. The first is VLAN scalability. For example, how to scale the VPN instance beyond the 4K limits. The second is MAC table scalability. Most layer 3 VPN solutions are using the MAC and map and encap scheme. So the core router, or the P routers forwarding table is now assigned to the number of the P or P routers number. So there's no problem for the core routers. But if we just extend the layer 2 domain across multiple data centers, the C switches, especially the commodity C switches, will need to learn more MAC addresses. Not only the local MAC address, but also the remote MAC addresses. So it will become big challenges. The third is broadcast term reduction. For example, how to reduce the ARP broadcast impact on the network performance and the host performance, and how to avoid the uneven cost flooding. The third is the multi-homing and the load balancing, so as to increase high availability capacity and to optimize the bandwidth utilization, especially the broadband backbone bandwidth utilization. Virtual subnet is a very simple idea. By using the proven layer 3 VPN and the ARP proxy technology, it can provide IP-only layer 2 VPN service. Compared to the existing layer 2 VPN solution, the virtual subnet has the following benefits. The first is suppressing the unknown unicast and ARP broadcast flooding. Since VS can restrict the reach of the flooding domain within a single site. The second is reducing the MAC table address of C switches. The third is achieving multi-homing and load balancing by using the VRP. This is an example of an intra-subnet unicast. On each P router, its local C host ARP entries will be learned automatically, and host routes for their local C hosts will be automatically generated according to their ARP entries. And then these host routes will be distributed across the backbone with the existing layer 3 VPN signaling. If host A wants to send a packet to host B, it will first send an ARP request for B. P1 at ARP proxy, when receiving this packet, will return its one MAC address to host A. Then host A will send a packet for host B with destination MAC address of PE's MAC address. PE receiving this packet will tunnel it towards the next hop PE router, P2. Then P2 will forward a packet towards the destination host. We can see here the forwarding behavior on the P routers is not exchanged compared to the current layer 3 VPN forwarding process. The difference is we use host route-based forwarding. This example of an inter-subnet unicast. Here, a gateway is connected to P2. Now, host A wants to access a host B, which is located in a different subnet. A will set a packet to P1 with destination MAC address with PE. PE is MAC address. And PE will, P2 is connected to the C gateway router, so it will be configured with a default route. Then this default route will be distributed to other P routers. Now host A sends a packet for host B. P1, upon receiving the packet, will tunnel its packet to P2 according to the default route. P2 then set its packet according to the configured state route to the gateway. Here, if two C routers, for example, are connected to two P routers, respectively, for gateway redundancy purpose, only the P router which can connect to the WebP master will be allowed to advertise a default route. We can achieve this goal with a very simple way. For example, next hop the default route is set at the virtual router IP, and that default route will not be deemed as valuable until there is a host route for the next hop address. That's the next hop of availability trick. Local C hosts are automatically discovered by P routers through ARP learning mechanism. To keep those learned ARP entries from timing out, P routers should send a unicast ARP request to those known C hosts. To ensure the P router could learn all its local C hosts in a short time, especially after rebooting off due to some reason, the P router should perform at least once a host scanning. For example, the P router could send an ISMP echo request to an IP broadcast address. Every C host receiving that request will respond with its ARP reply containing its IP to MAC mapping. In this way, the IP to mapping mappings can be learned by P routers. By using ARP proxy on P routers, ARP broadcasts are contained within a single site. For example, if an ARP request for a local C host received, the P router just discard it. For an ARP request for a remote C host, the P router should return its own MAC address. For an ARP request for unknown C host, that is, there are no matching host route for that destination host, the P should discard this packet. In the C multi-homing scenario, where P is enabled among the P routers which are connected to multi-home site, and only the WebP master is allowed to act as ARP proxy. In this way, active multi-homing for the incoming traffic can be achieved. Since all P routers attend to a given multi-home site can advertise the host route for their local C host. When a C host, for example, a VM, moves from one VPN site to another, the P router attend to the new VPN site will advertise the host route for that C host when receiving greeters ARP message from that C host. And the P router attend to the previous VPN site. Upon receiving the above host route announcement, we'll send an ARP request for that C host to check whether that C host is still connected to it. If not, the P router will discard the corresponding ARP entry and withdraw the host route for that C host, which had been advertised before. Otherwise, it was just as a C multi-homing case. For customer multicast and broadcast traffic, MVPN technology, including the egress application mechanism, can be used without any change. Here, the customer broadcast traffic will be processed as a special customer multicast traffic. This is a brief comparison between VPS and the virtual subnet as a DSI solution. VPS cannot reduce only unicast flooding across multiple data centers, but virtual subnet can achieve that goal. VPS do nothing about ARP broadcast reduction, and the VS can reduce the ARP flooding by using the ARP proxy technology. Since the layer 2 domain is just extended across multiple sites in the VPS solution, the C switches need to learn not only the MAC address for local C host, but also the MAC address for remote C host. In the VS solution, C switch only need to learn local MAC addresses. VPS cannot support active multi-homing, but VS can. In case of a C failover, the triggered MAC withdrawn in the VPS solution will cause only unicast flooding in a short period, while in the virtual subnet solution, traffic flood will not happen. Thank you. Comments or questions?